everybody. Hello and welcome for the stream. It's great to see you here and interested in some MATLAB. So, before we get started, I want to just introduce myself. I'm Steven, and I'll get into my introduction a little bit more when we see our slides. But yeah, just let me know if you can hear me okay, if the stream is going good. You can send a quick chat just to let me know there's somebody else out there on the other side of the screen. I really appreciate it when folks do that. All right, someone just says, hello, Stephen. Hello. Thank you for sending a message. It's great to hear from you. Great. A bunch of messages actually from Shank and Shemari, Shrikant, Shabankar. Great to hear you. And wow, Warren Peaches. Hi, first MLH event here. That's great. Good to see you. Welcome to our community. All right, so now that we've got a few folks trickling in here, I want to get us started with our workshop. But before we do, it's super important, y'all, that you check into the event. I want you to get credit for the event. I want also to track, who is interested in our content. Do you like MATLAB? Do you like this time of day for for having a stream? These are the kinds of things we think about when we get these check-ins from you. So super important for you to check in for our event. Christine, hi. Ron Axel, hello. I remember you from the TaiPi workshop. Glad to see you again here. Yeah, I hope you had a good evening. But yeah, so why don't we go ahead and start with our presentation today. And as I mentioned before, machine learning tools in MATLAB is the title of our workshop today. And actually what we're going to do first, before we get into the machine learning tools, we're going to actually take a quick run through MATLAB because it's kind of a less common language than something like Python. And it does have its own rules. So we're going to just do a primer on that so that you feel confident when we're working on this machine learning stuff in what you're writing. All right. But as I mentioned, I'll get a little more into my introduction. So my name is Steven. I've been a coach at Major League Hacking for over 5 years now, actually. I started back in 2018. And before that, I was organizing hackathons at my school. So I started organizing hackathons back in 2017. And yeah, it was just an incredible experience, and I wanted to keep attending them. So I continued attending those hackathons and eventually got into this community. And since that time, when back then we were a community almost 100% in person, almost 100% North America, a little bit of some Europe events, but now we've expanded to other continents, and we've also taken our stuff virtual. So we have so many virtual things you can participate in, and that just has really grown our community and allowed us to reach so many others and meet so many of you great people out here in the chat. So people like Kansas, USA. Great to see you from Kansas, and we can all log in from the comfort of our homes or wherever you're getting your internet from. But yeah, so that's kind of a bit of a ramble. But before I keep rambling and keep telling you random things, why don't we take a quick survey to get to know each other a little bit better? So in this survey, I'd love it for you to complete it. I'm just going to be asking you to tell me a little more about your experience with the topics of today's workshop And I also am going to be asking you, a fun question. Where are you logging on from? And so hopefully you can answer those questions for me, and we'll look at the results together in a couple of minutes. I'm just going to give folks a couple minutes to fill those out. But here's Ralph. Hi, Ralph. Good to see you again. Thanks for joining for the stream. Yeah, I get the sense this is a pretty good time of day for a stream. This early morning. For me, it's morning time stream. And I think it's not too bad of a time for most people. So but hats off if you are attending at a late hour for you. We appreciate your commitment to the stream. Vishal says hello. Hi there, Vishal. All right, well, why don't we go ahead and look at the results of this survey. So far we've had 17 responses. That's a lot. And why don't we go through and check what these responses look like. So I have in the share screen now the survey results, and we had, oh my goodness, 24 responses. The responses are really climbing up. That's great. And have you heard of machine learning? 100% of you have heard of machine learning. That's great. I think everybody on planet Earth has heard of machine learning in some way at this point. It seems, at least from our little slice of the tech community. But then this is a very different picture. Have you built anything with MATLAB before? And 86% of you said no. So I think this is really telling, and I'm glad we're starting with some of the intro stuff here with MATLAB so that we can really get everyone up to speed on the syntax and things like that. And then, have you trained a machine learning model? We have a few folks in the chat, maybe 1 in every 3 of you who have done this before. You have trained a machine learning model. And by the end of this workshop, you'll all be able to say that you've trained a machine learning model. But 2/3 of you still said no. So we're going to go over that as well. And finally, are there things you'd like to learn about machine learning? 97% of you said yes. So that's awesome. And this is AI ML week, so I hope that some of you are here to learn some machine learning. And I'm glad that we're able to do that, and so together. And so now I want to zoom in on our regions here. This was the fun optional question, just to see which continent are you logging on from. And I think we have a majority here of Asia hackers. So welcome to all of our Asia hackers. And I think the last time I did a stream yesterday, I think I did one in the evening here in North America. We had a majority North America, so I can see how the regions are changing a little bit depending on the time zone that we have. But yeah, and then this last question is, don't forget to check in, right? And just don't forget that. I'll send the check-in link one more time in the chat so that everybody has it and that we can get as many as possible. Yeah, wow, it's night. I know, and I just checked the IST, and I see it's 11:30 IST. That's pretty late, but not terribly late either. So that's good. Yeah, so a quick survey, and now we can move on to our intro to MATLAB. So first, I want to get all of you set up with a MATLAB account, and with a MATLAB account, you actually don't need any kind of license or oh, the check-in link is for another event. Sorry. Thank you, T-Rex, for sending that. Let me get the right link so that everybody can check in to the correct one. It's kind of important. All right. Here's the correct event. I hope, yeah, I hope you didn't go and check into the wrong event. I wonder what that is a link to. Let me see. Oh, that's my previous workshop, the one we did yesterday. But this is the correct one, 10996. go ahead and check in there if you haven't already. But this link, MATLAB Academy, is going to send you to what we call the self-paced online courses. Okay, and so this is where we're gonna send you in order to get some educational resources for MATLAB. And actually, they have so many courses here, not just on machine learning and AI, but also on modeling, optimization, signal processing, really a huge amount of stuff. And I highly recommend you check that out. And great, Ron Axtell says, I already have one. That's awesome. And so if you don't have one, make sure to get one. Okay. All right, so when you make your account, I just want to flag this. They will request an email address. So let me check this here. Yeah, so they will ask you for your email address. If you're on this page, you know you've done the right thing. Create one. You do need to be at least 13 to get a MATLAB account. And you can write your location. You could write that you're a student, because we are all students here at Global Hack Week. And yeah, that will be totally fine. And yeah, what are the prerequisites? There really are none. We're gonna go from ground up here with MATLAB. And eventually, at the end of the workshop, we're going to be able to program our own machine learning workflows. But yeah. All right, so let's move on to the next slide, which is going to be working together through the MATLAB Academy. And I want to get started first with the on-ramp course. So let's navigate to this course. I need to sign back into MATLAB. Just give me a second, everybody, to do that. I can't remember. I can never remember my password to anything. I don't know about you all, but it's a daily struggle for me. But yeah, so this is the MATLAB on-ramp course by Renee Coetzee. So thank you, Renee, for putting this together. And we are going to be going through this together live, and I'm going to make some comments about what we're doing. So why don't you just go to the very first section, which is about commands. And yeah, as you said, we're always dependent on password managers. Yep, I rely so much on my Google Chrome for that. And I wonder about that too, because I don't know if you all have noticed this, but all of these IT companies, they are always telling us, change your password, have a different password for everything. But if my password manager always knows the most up-to-date version of all of my passwords, couldn't someone just hack into my password manager and take all of those? So I always wonder about that, and why it is that we have to make all these different passwords for things. I suppose it makes sense if to a certain degree. But anyway, so, and we have another question here. Oh, sorry, that's a question for IM 45145. So I guess we don't have a question. Oh, how do we get here? Great question. Thank you for asking that. And the answer is that you're going to use the link I showed in the slides. So I'm gonna send you the link in the chat directly. So yeah, you go to MATLAB on-ramp, and then you'll click on the commands. Okay, the commands section, and it should build you an environment that looks a lot like this. And we can actually play with our MATLAB environment now. We can do commands, really simple ones, like 3+1, or we could do, I guess you do escape to try again. So 5 times 2. And it gives us the answer. And actually, MATLAB stores the answer. So it stores the return of whatever line it is automatically in this ANS. So I think I guess it doesn't work because of the fact that you're restarting every time, but ANS then would be stored. Let's see, we can do all these different kinds of operations, but task 1 is for us to do 3 times 5. So we can just see that we have these operations available to us in MATLAB. And yeah, you can see what I just meant. So unless you specify an output variable, MATLAB will store it in this ANS variable. So you can actually then call ANS. I'm not sure if it will allow us to. Yeah, there it is. ANS equals 15. Okay. So if we do 7 plus 3, we get ANS. But we can also assign to an arbitrary variable. So we're going to assign to m now. M equals 3 times 5. I'm going to make this a little bigger for all of you. Okay, so there's this question, what to do on link your account to a license? You actually don't need to put anything there. You can leave that field empty. And if you do that, you will still be able to use the MATLAB Academy. So that's a great question. Thank you for asking it in the chat. And yes, the answer is you do not need to link your account to a license. You'll see it actually says optional there. All right. So now we're going to continue along here. And I'm going to show the result of this. So you do m equals 3 times 5, and it stores it there, just like a normal programming language. Although this ANS thing is a little bit different than what you might see in Python. The equal sign is an assignment operator in MATLAB. So it's similar to Python or any other standard programming language. So first you could define m, and then you could define m equals m plus 1, and it will now assign the value of m to 16. Okay. And you can see here that on the workspace tab, we now have the variables from our playing around in this playground. We have the ANS value that's stored and the m value. And it tells us create a variable named y that has the value of m2. So we can do that too. All right. When you enter a command without a semicolon, MATLAB will display the result. And this is something that's different than Python. So if you're used to Python, you're probably not used to these semicolons. And semicolons are telling MATLAB that, in other words, this line is over, but we want to add another line underneath. So that's how these semicolons can go. And you can see the purpose of the semicolon is that the result is not displayed. So if we type x equals 5 plus 1 and a semicolon, or I guess in this case we want k equals 8 minus 2 and a semicolon, then look, the value of ANS is still 15. Right? So that's a big difference between Python and MATLAB. Okay, so definitely remember this semicolon thing here. You can recall previous commands. Oh, let's go back here. By pressing the up arrow key. So when you're in the MATLAB Studio and you type up, it'll cycle you through any of these previous commands that you did. And you can do the down key to go down. So yeah, you can get any of this stuff back. So let's get our 3 times 5 back, and we'll do 3 times k now. And you can see in the workspace, k is 6, if you forgot what it was. So when we do enter, we get 18. Right? And when you enter just a variable name at the command prompt, MATLAB displays the current value of that variable. So let's go ahead and type y, and you'll see that y equals 8. All right. So for our further practice, it says the value of y is unchanged because MATLAB does not rerun previous commands in the command window. So what that means is that we aren't going to have any recalculation of y based on the new value of m. So we need to actually then specify that y equals m divided by 2 in order to get that to go again. So now y has changed. Right? And that's also true in Python. All right, so the next step here is to go to our name variables. And we're going to talk about the naming conventions for MATLAB. You can name your MATLAB variable anything you'd like to, as long as they start with a letter and contain only letters, numbers, and underscores. So it's really similar to a language like Python. And also that the variables are case sensitive. So let's create A, and we'll assign it -2. So we can use big A and little a to calculate A plus A divided by 2. And we'll store the result in mean AA. That's kind of a funny instruction. So what we can do to solve this is we can use parentheses to evaluate A plus A first. And you might wonder why we need to add parentheses. It kind of might remind you of some of these Facebook posts where they'll say, "Oh, what's the solution to 4?" They'll say something like this: "What is 4 divided by 5 times 6 plus 3 minus 1 divided by 3?" And you have to figure it out. And everybody in the comments section is arguing, "What's the answer? What's the answer?" I don't know if any of you have seen this. But yeah, it's very common on Facebook and things like that. So, I have a question actually. Is MATLAB also interpreted like Python? And the answer is yes. Yeah. MATLAB is an interpreted language. And Ralph said, like C. Yeah, exactly. With all the semicolons and everything. Exactly. What's 2 horse plus 3 bike plus 1 dog equals 100, right? Yeah, you'll see all that kinds of stuff on Facebook. But so we can use the A plus A divided by 2 to get that result back of mean AA equals 3. And if you use an invalid variable name, you'll get an error message, and MATLAB will suggest a correction. So do you know what the error is here with this code, 3SQ equals 9? Does anybody know? And Param says, what's the average salary and demand of a MATLAB developer? Well, so I think a MATLAB developer would probably fall most closely under a data scientist. And I'll just show you, for a data scientist, you can see, at least in the US, you have a median pay of maybe $50 per hour here in the US. I'm sure it's very different from place to place, but this is the type of role. So you can what you actually can see here is what data scientists do, the work environment, things like that. It's because MATLAB is really a great language for visualizing data and processing that. Oh, oops, I lost my interactive command window here. But I'll post that as well in the chat, because this is actually a very good resource for folks who are interested in data science. And yeah, I see T-Rex, IM45, Incredible Brain, Warren Peaches, Shrikant, excellent work. You've discovered the issue here. We aren't allowed to start a variable with a number. And that's true of so many programming languages, actually. For some reason, You're not allowed to start your variable with a number. And I can kind of see why, actually, because you could imagine a situation where somebody confuses this with a 3 if the programming language is looking at it, and then it realizes later on that it's actually a variable and not a value. So I can kind of see why. But yeah, if you type 3sq equals 9, we get an invalid expression, and it'll tell me, did you mean sq equals 9? And you can say, sure. Because now we don't start with a number anymore. But we have a question here. Why use MATLAB instead of Python or something else that is free? And that's a great question. So in MATLAB, you have a really good documentation. So I think the MATLAB documentation is so much better than the Python documentation, personally. That being said, you don't have as much capability as you do with open source Python, and so you do have a trade-off there. If you need to do something very particular, or that's only available, it might only be available in Python. You may not be able to do it in MATLAB, but the documentation for MATLAB is just really excellent. Let me show you even an example of this, of what I'm talking about when I say that we have really good documentation here. So here, I'm just on the MATLAB documentation. I'm looking at 2D and 3D plots. And, it tells me, okay, we have all these different plots. So why don't we look at one of these plots? How about an animation plot? I want to learn how to make animations. So look, you can see it's organized into all these different animations. Let's say I want to create an animated line. It tells me the syntax, the description, and this is something really cool. It gives me examples. All right, so I can actually see, oh, here's an example of how you could do a display line. And you can get this code and try it out yourself. All right, and there's just seemingly infinite examples, and you can see what are the different arguments that can go in here. So anybody who's looked at the Python documentation knows that they have a lot of really great stuff there, but I think that MATLAB documentation is, generally speaking, really rich. So that goes back to your question, Defendant 2511, which is why use MATLAB instead of Python or something else that is free. And yeah, so Nira Jason says, is MATLAB used for maths or visualization? Exactly. So I would say the biggest application of MATLAB is data processing, data visualization, data science, really. Ah, there you go. So there you go. It has to do with compiler design, I guess, this requirement. And Puneet says, will you teach R also? Not in this workshop, but I think RStudio is another great example and has a lot of applications to data science and statistics in particular, the field of statistics. So let me put a statistician as well. This is another great resource. I think these are really cool resources. I know they're very US based, the Bureau of Labor Statistics. It's just what I know because I live here in the US, but they have great details, not just on US specific stuff like what is the salary, what is the demand by this US state, but they have pages about like what sorts of things can you do, what sorts of environments would you work in as a statistician. And I think that is very universal advice, or at least much more universal than and so I highly recommend to check out their handbook there. Yeah, but another question. Oh, and actually, I should say, Warren Peaches says, if I recall correctly, a lot of existing code in fields like civil engineering and aerospace rely on dynamics models built in MATLAB. That's an interesting fact. I didn't know that, but I know there's a lot of signal processing and other engineering applications built into MATLAB. So that could be another thing if you're interested in engineering. Simulation is huge for MATLAB. So we have another question. Is there a difference between companies that require MATLAB and over Python? I don't know of any companies that ask for it. That's a good question. I guess I wouldn't know the answer to that. My general sense is that you should be learning the skills of a data scientist. It doesn't really matter which language you're using to learn those skills. And once you have those skills, you can pick up other languages if you need to. And the incongruent says, I just had one doubt. Can we solve the challenges through these workshops? Yeah, absolutely. So let me point you to the challenges, actually, because this is a really common question that we get. So I'll paste the link in the chat to the challenges. And so let me share the screen as well. I'll show you. We have so many challenges. So we have our featured challenges. And these are just around the whole week, so you can complete them at any time. So don't worry about completing them right away. But then we also have our today's challenges, and these are going to be only for day 2. And so you have to finish these by the end of the 24-hour period. It just started, so lucky you have plenty of time to do so. But there are things like join the MLH Discord, which is also a feature, or no, which is one of today's. But complete the GitHub Copilot primer, and make a personalized list of must-watch shows with Oracle. So you should just check these out. And by the way, some of these challenges are going to be useful for other ones. So you have implemented data structure, but you also have process a data set, build your first AI ML game. All of these are going to be super related. So that's just to look at a few of these. And I highly recommend you to also check these tags. You have beginner tag, which indicates, and no code, which they indicate that these are things you could easily do. All right. So yeah, I really recommend you to check those out. Yeah, let's go back to our intro here. I'm going to zoom in a little bit because I want you to be able to see everything. But another thing you can do is save your variables in your workspace to an MAT file. So MAT files are the way that MATLAB stores data. Have you ever heard of an NPY file? That's a NumPy file in Python. Well, it's really similar. It's a really similar concept, actually. And so, MAT is like a data table that gets saved in this language. So we can type save data file .mat, and that will save this data set that's in the workspace, and essentially saves your entire workspace. You can empty the workspace using the clear command, and so now all those variables go away. And if we load our data file back up, bingo, there it is. If you have a variable in the workspace, you can quickly display that. And you can use clear, but you can also use CLC to clear the command window. So that just doesn't clear your workspace, but it just clears these commands and makes it a little cleaner up here. And before closing MATLAB, you can always use these mat files to save your variables, and that way you kind of have all of your data saved. It's really preferable to just clearing out immediately. This is interesting too. You can load a particular variable from the data frame. You don't have to actually load the whole thing. So in this case, I just loaded K, and I can save it back into another MAT file. That's kind of cool. And we have built-in functions and constants. So pi, for example, is already defined in MATLAB. You can just easily store that. So let's create a variable with pi over 2. There's also trigonometric functions in MATLAB. So you can calculate the sine of x and save that to y if you want. There's square root functions. So you can say z equals square root of -9. It'll even tell you the complex numbers here. And finally, in this section here, that was an imaginary number, which is a built-in constant. And if you want, you can format these. Totally differently. Oh, sorry, I think you have to go format long and then x to show that versus format short. All right, so that concludes a basic overview. I don't think we're going to go much further on that. But I want to just see if anyone has any questions about what we've done so far in terms of commands. I might come back to this a little bit, but I just wanted to give you a sense of the basic commands in MATLAB before we got into our machine learning topics. Any questions here? All right, so why don't we then dive into the next step here in our project, which is going to be the machine learning part. So thank goodness we're going to finally do some machine learning. I know this is what all of you are excited about for AI and ML Week. And we're going to learn some of these first concepts of machine learning. And Dizzy Roo says, yay, we haven't covered movie recommendation systems in our data visualization lessons, so building one is a bit beyond our current scope. That's true. Well, so yeah, I think as far as recommendations for movies, I don't know. Is that something that UT is planning to cover in part 3? I'm not sure, which is today, actually, I think. So you could wait for that workshop and then build the project. But yeah, I mean, just give it your best shot, really. And, you can definitely do some things like you can build the front end part where you're building a data visualization and having some inputs come in there. You can already do that. And as far as the machine learning algorithm itself, yeah, I don't think we've done any recommendation systems yet, but it's definitely in the works. But yeah, so I want to give you a quick primer on machine learning. And yeah, this is a good question. Shemri says, the only streams you can redeem your channel points are in Dimmer stream. That's absolutely right. Yeah, I'm sorry. I haven't really invested the time to figure out the channel point system, but I know Dimmer has a great resource on that. But yeah, it's just unfortunately not in the wheelhouse yet for me. But yeah, so with this machine learning primer, I want to just give you an idea of what machine learning is. There's a lot of hype right now on this topic, but really machine learning, it comes down to doing statistics and extracting information that is useful information from data. So for example, you could detect spam emails from email data. That's an example of an algorithm that we will also be working with today called classification. And so we're going to learn some of those today and how to implement them in MATLAB. And the machine learning pipeline has several components, but I want to start by talking about selecting your data set. And a lot of people will brush over this topic and say, oh, well, I get my data set on Kaggle. That's how I get my data. or I got it from the tutorial, and that's what we're going to do today. We're going to get our data from tutorial. But I want to really emphasize how important selecting your data set is, because you need to choose the highest quality data possible. Data has a lot of noise in it. So I'm going to type this in the chat because it's so important. Data equals signal plus noise. Okay. Imagine that you are trying to eavesdrop on a friend's conversation. It's kind of a dark example, but it's what came to mind. Well, you might be you're collecting data with your ears, right? You're listening in and trying to tell, what are they saying? Are they talking about me? Is this something I need to know? But the signal itself would be their conversation, but might hear some noise in there too. You might mishear something. A train might go by in the background, and you don't catch something. So your data that you're collecting with your ears doesn't have the pure signal. It also has noise in there. I am 4 or 5 says, you are what you think. Steven's planning something here. Yeah, maybe I'm planning to be a spy. I'm not sure, but I don't think I would be a very good spy. But I guess that's for a future workshop. How to be a spy. Maybe I'll do that one time. But sorry. But yeah. So here's some things you need to consider. Do you need precise data or data with large coverage? So we deal with this a lot of the times in my field. So I work in geospatial science. We are dealing with two different types of products. We have stations, weather stations, where very precise data about temperature, wind speed, we pick all of that up. But then we also have satellite data, and satellite data is going to be broad coverage. So you can get satellite data from all over the world, but it's not going to be as precise as a station measurement. So that's a huge difference between precise and data with large coverage. We have a fun fact from Warren Peaches. Data means what is given in Latin. I didn't know that. I'm going to trust you on that. That's super interesting. I really like that, actually. But then we have another thing. Will you use freely available data, or do you need to request it from a third party? So a lot of folks don't know this, but much of the best quality data is unfortunately behind a paywall. And so if your company is trying to access that data, you may need to purchase it from a third party. Now, I don't deal in this area, so I don't know too much about paid data, but it is a consideration to make. And then the speed of the data access and download is super important too. You could have a server, you may have a great internet connection on your end, but you could be connecting to a server that is super slow. And let's say that your data set is 500 gigabytes, which is not uncommon at all in today's world. Accessing that data, even just reading it, if you're doing it over the cloud, that's going to be a huge challenge. And finally, we have the size of the data set. So as I mentioned, a 500 gigabyte data set could be small these days. And the size of the data set can get into the terabytes. And so what you need to do is figure out what kind of data set size can I support on my infrastructure, and how can I do that? Yes, and that's right. Data brokers. These are data brokers who would sell data for machine learning purposes, and college to course sellers. I mean, you can get into the ethics and the whole debate about data, and it's super interesting topic. Maybe we should do that. Actually, I think that would be great. I know we've done some AI ethics workshops in the past, but really data is its own thing. I mean, figuring out what the ethics of data sharing, especially with these AIs, would be cool. Yeah, sign me up. That would be super cool. I'm sure we could get some expert to come talk to us about it. But yeah, our example is where the data is from the MATLAB Academy. And we're just gonna not question that. I mean, it's really simple data. This data is drawing from it's drawings of letters. So we're gonna see how these letters have been drawn, presumably by humans, and based on that data, we're gonna classify them. So I don't know if you've ever used on your iPhone, um, a keyboard that allows you to write. I know they have them for English. We have like ABCD. You can actually draw on your iPhone, and your iPhone will pick that up. So we're going to kind of build uh, an algorithm that will accomplish this sort of thing, and that's our goal. But Shemri says open data is a decent source, and going directly to websites seems to be workable. Yeah, there really is so much open data. And for many applications, it is a great resource. But there are even some fields where it's just not feasible. Here's a great example: healthcare. Okay, if you want to make a healthcare application, oftentimes you will need private data from hospitals or from pharmacies or from somewhere, and that is also people's private information. So it's not openly available, and you may need to discuss with the hospital or with the government, in some cases, to get access to that data. Tell them why you're using it. So it is a great source, but for some applications you need to go a little bit further. Yeah. Does anyone else struggle to find synonyms for data? I don't. Yeah, I kind of don't have any other words that I guess I would use. Maybe information or I don't know. That's a really good question. And yeah, Ralph says, let's try fishing. Let's not even joke about that. Oh my goodness, such a problem. But yeah, actually, I think we have a security week also in Global Hack Week, and that might be a good place to talk about this sort of thing too. But yeah, no, it is a very serious topic. Um, but yeah, so we're going to learn how to import data in MATLAB Academy. So I have this link that I've sent and set up for you. And this is how we're going to get started with importing this data from MATLAB. Yeah, this is cool. Healthdata.gov. That's cool. I never knew about that website, Marie. And this is just why our community is so great, because you learn so much new stuff. I might even look into this later today, this website, because I'm interested in doing some machine learning project for health, um, which is why I was kind of looking into this. But yeah, security week, so your security ain't weak. We should make that the logo, I think. That would be a great logo. But yeah, I pasted it in the chat, this link as well, on how to import data in MATLAB, and let me show it live too. I want to show it live. Oops. I almost just shared with you all the StreamYard stream that I'm in right now. I almost shared that on the screen. That would be kind of funny. All right, I didn't even know that was possible to share your Stream Studio. That would be like a mirror. Like, you ever see those mirrors that tunnel in? Those are kind of funny. Yeah, we're all going to join the stream. Wouldn't that be great? Maybe we should do actually some more interactive streams where we have some guests. That would be kind of fun. But yeah, so here, this is the handwriting data I was talking about, and this is just a picture of it here. So the data has these 4 columns. There's time, and time is actually, you also need to think about what are the units. And so the units are milliseconds since the data collection started. X and Y are the positions on the screen. And P, I believe, is the pressure. So the pressure could be from 0 to 1 if there's any data collection happening. 1 would be like fully pressed down, and then 0 would just be like lifted off. And so, of course, there's no position when the pressure is 0, because you don't have that. But then you can imagine having this data mapped to a letter, right? I mean, it's really something that the user has written. All right, see you later. I am 45. Bye now. Take care. But yeah, so this data could be mapped to an actual letter, and we're gonna deal with this data and categorizing it today. All right, so we'll close out of this. And in MATLAB, you're going to use a particular function called read table to get this data into the system. All right, so we'll type data equals read table, and then we'll read the data table j.txt. Actually, the task says to type letters, so I think it will only work if I do that. But remember, you can test your work by submitting here. But now our data has been imported from a text file into a MAT table here. So we have a 27 by 4 table with all of our data. So that's great. And in MATLAB, we can use the dot notation to refer to any individual variable within a table. So if I want to type x equals my table dot x data, that will give me the value of the x data column, which doesn't exist in this table, but just as an example, stored in the x variable or vector. We actually would call them a vector in MATLAB. But let's try visualizing the letter by plotting the x variable of letter on the horizontal axis and the y variable on the vertical axis. I think the way you do this is by plot. So we could just plot letter.x and letter.y. Let's try it. Oh, let's see the solution. I think it might be scatter, actually, for this one. I always forget. No, it is plot. Huh, I wonder why it didn't work then. Let me zoom out a little bit so I can see a little bit better. Oh, it's because I wrote the letter wrong. This is what happens when you do a live demo, everybody. I should have known from that graph, but yeah, you can see that the letter J now plots. And the next task we have is to check out the default axis limits and change those. And this is an example of just data visualization. So oftentimes when you are dealing with a plot, this can be in Python, in MATLAB, in R, in any language that you are primarily plotting things, you will see a distortion of the axes, and it can really mislead your reader. So if you're showing this graph to a user or an executive in the company, you don't want to mislead them with weird wonky axes. So it's always good to think about this, actually. But what we can do is use the axis equal command to do this. So you just type axis equal, and it normalizes our axes so that each axis has the same scale, and now our J looks a lot more normal. All right. And finally, we're asked to do the exact same practice, except we'll do for m.txt. So why don't we do that now? And we're going to do the exact same thing that we did before. We'll do letter equals read table, but now with m.txt as the file name. We plot the letter, oops, that's in Python. We plot the letter x and y, and we type axis equal. And here's our m down below. And yeah, this could be real user data. I mean, you could imagine someone drawing an M like this with their hand or with their mouse. But anyway, um, you could do this also for V. I think this is the last letter that we analyze in this machine learning application is V. There it is, good old V. Yeah, we'll move on to pre-processing data, and I want to talk about pre-processing data before we get on to the workshop, actually. So pre-processing data is the act of massaging the data into a usable form. And some examples include removing and replacing NaN values. So, we had some NaN values that we looked at in our drawing itself. What are you going to do with that data? Is it valuable? Is it useful? How do you remove or replace it to account for its presence? And then rescaling values is something we also do. So, what you could do is remove negative values. For example, let's say you need to do a logarithm transform. Have any of you done logarithm transforms before? Let me show you what a logarithm looks like. So sometimes you might need to transform the data into another form, and a really common thing to transfer to is a logarithm, because they act in orders of magnitude. So earthquakes are a great example of this. We just had an earthquake here in California. I felt it yesterday. I was shaking around. It was actually one of the stronger ones I felt before. It was a 4.8. So magnitude 4.8 earthquake. I've not really felt anything stronger than this one. But during the new year, we had a magnitude 4 earthquake. And so I want to just point this out to you. 4 is, or a 5 earthquake, which, 4.8 is almost 4. A 5 is 10 times stronger than a 4, okay? So it's a way of representing, using logarithms, the scale of these things so you can understand them better. But when you're using logarithms, you have to remember that negative numbers are not allowed. So if you look at this graph here, unfortunately, log is only defined for positive values. So if your data has negative values and you want to transform it into a log, then you need to scale your data and remove all the negative values. So that's a super common pre-processing technique. Yeah, exactly. You're essentially telling the number of digits in a number by using a logarithm. That is basically what you're doing, especially if your logarithm is a log 10 scale or a log 2 scale. And yes, many times you feel it stronger depending on how close you are to the epicenter. Yeah, I was pretty close to this one, which is why I felt it so much. And actually, it drops off like 1 over r squared, I think. So the further you are, let's say you're twice as far away, you're 4 times less impacted, generally. But I know there's some more nuance to that as well. But yeah, so this all gets back to our pre-processing stuff. So you can transform values, and this is, you could use a logarithm, but you could also scale using 2 really common things: z-score and normalizing. So normalizing data, I put the equation up here. It's data minus the minimum divided by the range, which is maximum minus minimum. And this transformation of your data will allow you to put the entire series on a 0 to 1 scale. Okay, 1 being the highest data point in the set and 0 being the lowest data point in the set. And this is really common because machine learning algorithms generally, especially deep learning algorithms, they generally take as inputs these normalized values, because when they pass through the layers, the layers of the algorithm, the fact that all of the variables are relatively similar in terms of the order of magnitude, is really key. So let's say your machine learning algorithm takes the temperature of the day and also the amount of rain, okay? So temperature would be reported as something like maybe 25 degrees. But let's say there was only 0.0001 inches of rain. Well, we want to make sure these things are on the same scale. So if you normalize them, they will be. All right. And then we have an equation for standardizing data too. This is another really common transformation, and it involves rescaling the data by subtracting the mean and then dividing by the standard deviation or the spread of the data. So it will also bring all of your values relatively close to each other, which can be really good for certain machine learning applications. But yeah, let's try it out in MATLAB Academy now. This is what we were looking at before. And so let me actually share my tab again. And I'm going to zoom in a little bit because I want you all to be able to see and it not just be me talking and you have to kind of rely on what I'm saying to you. I hope we don't get to that point. But you know, the first task here is saying you can use dot notation to extract, modify, and reassign variables in a table. So we were doing that actually just a minute ago. You could say data.xval equals data.xval plus 3, and it will actually update the table values too. But in this case, I want to tell the program to multiply all of the x variables by 1.5, and we'll reassign it back to x. All right, so we're taking the variable, multiplying by 1.5, and reassigning it. So now it's actually been permanently changed in our table. So you can see that it used to be 0.73 here, and now it's 1.104. Totally different. And here's another example. We've said normalize the time, you know, get this time to be from 0 to 1. And we can do that. So the way we'll do it, we want to first know that we can get the last variable in a vector. So vector is just a string of these variables, these data points in MATLAB. You can get the last value by typing end. And then we're going to shift the time so that we start at 0 and convert the values from milliseconds to seconds. Just need to check this really quickly because I want to make sure I do it right. Yeah, so we're actually going to use time as the variable, so letter.time. And we're going to take all of the times, and we're going to subtract the first time. And this is a very big difference between MATLAB and Python, is that the first time in our data set is not 0. We don't go like this. If we were to use Python or some other, like C, I know someone mentioned C, we would use 0. But we actually are going to use 1, parentheses 1. All right. And then we are going to further transform this value from a millisecond to a second. And the way we do that is by dividing by 1,000. So now when we look at our data on the time axis, you know, where it used to say 13,734, that's kind of a meaningless number to us. Now the time values are super uniform. They go from 0 basically to, they're on the order of 0 to 1. Some examples from NASA's project data. Maybe I will put that in for part 2. That's a great idea. Do some NASA data. They have plenty of open source data, and we can check some out. Yeah, I'll put that in for next time. Great suggestion, Samantha. Thank you. But yeah, so for now, we're gonna just keep learning on this example with our letters. So you could replace with J. Let's see, you can actually run all sections. So there's J. And V, we could see V also if we wanted to. All right, and we'll continue on with this by talking about extracting features. I want to go back to my slides here and show you. Oh, feature extraction. How can we distill our data into a smaller, useful set of features? That is the main goal of feature extraction. For example, let's say you tell your friend directions, okay? You have some data about the directions to get to the grocery store from your house. Your friend is staying over for the weekend, and you need to send them directions to the grocery store. Well, you're not going to tell them, all right, take one step outside of the kitchen and into the living room. Then take another 2 steps, and then take a 3rd step, and you'll be in the entry door. And then open the door, and then take a few more steps out the door and make a left on the street, and then take 15 steps, right? You're not going to do that. What you're going to do is say, all right, leave the house, go down the street until you see whatever street it is. Let's say Red Street. And then make a right on Red Street, and then go down until you see the gas station, and then 2 houses down, it will be there. The grocery store will be there, right? So you just told so much information to your friend, but you used very few words. And that's basically what feature extraction is. You're trying to get as few words possible, as few features possible, to tell the most information. And might your friend get lost? It's possible, right? Because you gave limited information. And if you maybe told exactly the directions, take a step here, take a step here, take a step here, I'm sure they would always get there, but they'll get there 99% of the time, and you saved, hours from telling them the grocery store directions. So that's basically feature extraction. And some key techniques you can use for feature extraction include principal component analysis, which is where you break down some higher dimensional data into a series of components that have most of the variance in the data set. It's a sort of a linear algorithm. You can use it on any high dimensional data. And then we have data transformation,